Force of gravity.
The natural force.
The what?
Natural force.
You mean normal?
Normal force, yeah. Sorry.
What's it touching? Normal force requires contact. What is it touching?
The string.
We're going to call that tension.
Okay.
Because I don't know how the string's attached to it.
So it doesn't have normal force.
No normal force. If you want to get rid of tension and call it a normal force, that's fine. But you're making assumptions that are not stated in the problem.
So it would just be tension.
Okay, which way is the tension acting?
Hold on. That way.
All right, I'm seeing several hands pointing in the same direction. Again, if you flash back to however long ago it was, tension is along the line of the tight rope or string or whatever, so I have a tension going this way. All right, so dum, dum, dum. Other? And friction? Because we are not dealing with that. Okay. So I got my two forces here. What is the direction of acceleration? This is the next step in the facades process. Wait, I got, oh, sorry, I couldn't quite see there. All right, so I've got 3 people pointing in the correct direction. It's almost a groundswell. See if we can get a 4th. There we go, we got 4. Can we get 5? 5 people pointing, all right, we got 5.
It was the direction of what?
Acceleration. Let's get a 6th and we'll stop it there. 6th person to point in the direction of acceleration. Is that, no, there we go. All right, we got our 6th. For those who did not point, I hope you were at least thinking to the left. That's the direction of my acceleration. Because the circle is like this. It's traveling, it's towards the center of that circle. Now, how do we know it's towards the center of the circle? I did not go through the derivation here, but there is a non-calculus derivation of it posted. All right, coordinate system. What direction am I and J? I hat, J hat. That should be better. I assume, is that enough?
Well, I definitely that way.
Okay.
And I don't know it would be easier to make positive up or down.
All right. Well, I saw your finger pointing that way, so I'm going to go with that one. Do you want to throw in the 3rd dimension?
Sorry, me?
Yeah, Dylan, you seem to be pointing.
No, I was trying to figure out. I don't thank you there.
What would be the direction of the angular velocity would be either up or down, depending on if it's swinging around like that or like that. Okay.
I still don't understand the angular velocity. I get the right hand rule, but I don't understand why, like, because that's the, like, compared to like a.
It's the problem that if this thing's swinging around like this, what's going up? I mean, besides, yeah, right hand rule says angular velocity is that way, but what physically is in that direction? Yeah. And sorry if I pushed my feeling onto you. That was the problem I had when I was first going through this. There's nothing physically going up. If I close that door, the angular velocity would be up. But there's nothing physically actually going up. It is purely a mathematical convention.
Because your thumb and then that's just the right hand rule.
Yes,
the way it is.
that's
Somebody made it up and that's it.
The powers that be set that down in writing. They said that's what we're all living with.
All right, just trying to grasp my head around that.
Yeah, there's nothing physically going up, despite my younger self thinking, wait, that makes no sense.
Okay.
It's very good.
That's all I need to do.
Blame the math people. So next time you see a math person, just throw the gauntlet down and say, I can't believe you did that. Did what? All of it. All right, we're down to decomposition. Do we decompose anything?
Yeah.
What do we decompose?
Tension.
Yes, because it is not in the I hat, it is not in the J hat, it's in some combination, so we have to figure that out. I do know this angle here. If that angle is theta, then this angle here must also be theta. Two parallel lines cut by a transverse, alternate interior angles are congruent. For those who've had geometry. If you hadn't had geometry, they're equal to each other. That angle there is theta. So I'm breaking tension up. I have a hypotenuse. Whatever I'm breaking up is my hypotenuse. I have some angle theta here. And that, make it a right triangle. Because breaking it into non-perpendicular components would just be torture for yourself. If that's what you're into, I'm not making judgment calls. So what would the horizontal component be?
Force due to tension times cosine theta.
And the opposite?
Force due to tension times sine theta.
Absolutely nothing wrong with what you said. Just letting you know, for tension, you can just say tension. So what I'm claiming here is that this tension that is moving up and to the left can be broken into two components here. An Ft cosine theta to the left, and Ft sine theta up. So my force diagram has now changed into, I have weight going down still, I have Ft sine theta going up, and Ft cosine theta going to the left. What's next? More questions? And then what's next? Any questions?
I was just saying, we're drawing it like that because that's the acceleration, right? That's the way the direction of the acceleration.
Since acceleration is to the left, we have our coordinate system so that one of the axes is to the left.
Okay.
And the other one's perpendicular to that. And so when we break it up, one of them, we'll break it into components that are in those directions.
Okay.
Does that answer it?
I was thinking that the resultant was pointing in the opposite direction because that's the way.
The resultant.
I think I might just misread your arrows.
Oh,
That's
this,
all right. Yeah.
this is what we're breaking up, so that's why I drew that in that direction.
Okay.
That should be in the same direction as that.
That's what I was. Okay.
I feel like there's still an unanswered question there, but you want to?
No, that's the force due to tension is going it back that way.
Yeah.
So yeah, that's okay. Yeah, we're right. We're good.
Right.
I just mixed my words up when I asked. Acceleration.
All right. I just erased it, but you should all know the next letter is E. What does E stand for? What's our next step?
Equation.
And again, our template, F equals ma. I'm going to have two equations because I have two directions in one object. What are my two equations? Now, if you're unsure of what I'm doing for forces, this is the key right here, that drawing, which I hope is in camera. It is just on the edge.
Can you repeat that one more time?
What's one of the equations? Given that this is our force diagram, what's one of our equations of motion?
Tension sine theta equals weight.
Say that again?
Don't they equal each other because they're equal and opposite forces? So the top equals the bottom?
You said Ft sine theta?
Yes.
Yeah, okay. That's the part I wasn't quite sure I heard.
Okay.
So I'm going to, ultimately, yes, you're absolutely right. I'm going to write it slightly differently though. We said up was positive, so if Ft sine theta minus the weight is equal to the mass times 0. Just want to emphasize the fact that we're justifying that the ft sine theta is equal to the weight because there's no acceleration vertically. If there's vertical acceleration, actually, if there's acceleration in both directions, we probably did not pick the best coordinate axes. A great deal in physics, especially as you get farther and farther on, is trying to pick out your coordinate system and your axes to reduce the amount of math you have to do. If you have not done the Boxall ramp the hard way, that video is a demonstration of, by not picking the most convenient coordinate system, how much extra work it is. All right, so we have our j hat equation right here. J hat. What is the other equation?
Ft cosine of theta minus weight.
Weight is this way. Ft cosine theta is that way. We're just doing horizontal right now.
That's as far as I go.
All right, so we got Ft cosine theta. Any other forces in the horizontal direction?
No.
Equals
0.
Mass times acceleration.
mass times.
Acceleration?
Yeah. And put a little c there just to indicate, I know it's centripetal acceleration. Yeah, when you're coming up with the equations, try not to mix different directions into one equation. It can be done, but not generally the simplest way. All right. What do we do after we have our equations of motion? What's next?
Substitute.
Yep. Do I have any independent equations for anything in here?
Weight equals mass times the force of gravity.
Again, try it again.
Weight equals mass times gravity.
Which is why I get picky about just the use of the term of gravity, because there are several things that are called that. Weight is the force of gravity, or is a force of gravity. You could just go with the letters and not worry about the words.
Well, I know
equals,
it's mg.
Yeah,
W
okay.
is mg.
What is g? Little g here.
The force due to gravity.
It's 9.8. So
What are the units?
meters per second squared.
So what is it, g?
Acceleration.
Yes, it's acceleration due to gravity.
Okay.
All right, so we have ft sine theta minus mg equals 0. All right, what about on the other equation? Do we have anything here? The answer is yes.
For centripetal acceleration, we could use speed squared over r, or r omega squared.
And I'm going to choose omega squared r in this case. Now, why I'm choosing omega squared r is not necessarily readily obvious at the moment. Just spoiler, it is going to make it a little bit easier. Of course, I haven't said what we're solving for, but we're just exploring. All right. Oh, I guess some length L, some mass M. I'm going to get some numbers here. Let's make this 0.7 meters and make the mass 0.3 kilograms. And what do I want to find?
Is that 7 meters? 0.7.
0.7. Yeah. Let's figure out what does the period need to be? So a problem like this on a test, I would break it down into parts. But. So the first equation, we can go to basically what Dylan said however long ago. Ft sine theta is equal to mg. This other one down here, we've got this r. What is r? Oh, I guess I get everything else. Let's give an angle of 43 degrees. How would you find r? Or is it given?
It's given.
Yeah.
So what is r then?
0.7 meters.
All right, thank you for the units. Anyone want to give a reason why that is not correct?
That's
Olivia?
the hypotenuse, and we need the one on the bottom of the CGs.
What's the circle that it's traveling through? Just finger in the air. How is it swinging? Horizontally. The radius has to be horizontal. R is this distance. That's R.
Oh, because of gravity.
0.7 cosine 23.
Yes. So we have the second equation, Ft cosine theta equals m omega squared L cosine.
I was thinking of this.
If you use just L for the radius, you would make the problem a lot more difficult. Because notice here, I now have cosine theta. This is why I did the omega squared R, is I have cosine theta. They will cancel out really nicely. Mark, erased. So I now have tension is equal to m omega squared L. And then however you want to work it out, I've got two, let's see, L I know, M I know, theta I know, G I know-ish, mass I know. I have two unknowns. I don't know omega, I don't know tension, but I have two equations, so life is good. Two independent equations. Well, we can just take that, plug that in for tension. At this point, there's several techniques we could take. This is just one approach. So I have m omega squared L is equal to, times the sine of theta is equal to mg. The mass cancels out. Omega is equal to g over L sine theta. Sorry, that's omega squared. We'll assume it takes place on Earth over 0.7 meters sine of 23 degrees. So if someone would be kind enough to figure out what omega squared is equal to, and then what we really want is omega. Omega squared somewhere around 50. Am I off by, what is it? 5.83. For omega or omega squared? Omega?
Omega. Yeah, I think square.
What is squared is 5.
Once you got this, you take the square root.
Oh.
It'd be 5.98.
5.98
Yeah.
units? Not for omega.
Radians per second.
Yes. Over here, looking at the units, the meters would cancel out, and we'd be left with 1 over second squared. And take the square root, you get 1 over seconds, but radians we can stick in, radians per second. All right, now the question was, what is the period? How long does it take to actually go around once? Well, I know what omega is. I know omega is the angle divided by time, assuming it's constant. So if I think about the time it takes to go around once, what is the angle?
360 degrees.
Or in radians, since we're in radians over there,
2 pi.
over the period. So I have 2 pi over the period is equal to 5.98. So my period is 2 pi divided by 5.98. .13.